Hi and welcome back. In the first part of this video we will clean the data, and actually there's not really much to do as we have only few missing values in one column. So it's the total bedrooms column, and there are some options how to deal with missing values. Either we can find an appropriate replacement value, for instance the median value of all districts, or more complex group specific mean or median values. However, in this case, we decide to simply remove all rows or all districts with at least one missing value with drop in A. And this shouldn't be an issue because we have only around about 100 districts with missing values. And in total, we have over 20,000 valid observations. Then we have seen that some features like median house value are kept, and also and even more important, the labels, so the house values are kept at 500,000. And there are actually three options. Either we can work with the kept values, or we try to find the unkept values, or that we can remove those values that are kept, which could be an option in case we are mainly interested in the lower price segment. And it really depends on the use case. And also we could check whether kept values harm the quality of our model and the model's ability to forecast labels. But this is beyond the scope of this course, but I have checked it, and at least with our random forest regressor, it doesn't really make a difference. We have several features that measure the size of the district, for instance, the total population, the total number of households, and also the total number of bedrooms and rooms. However, for our purposes, it could be a good idea to combine those features and create new and relative features. For example, we could be interested in rooms per household, and this is an indicator for the house size. And the intuition behind this is pretty simple. The larger the size, the higher the value. So let's create the new feature and the new column rooms per household by simply dividing total rooms by the number of households. And let's get the 10 largest values. And obviously there is a district where we have an average rooms per household of 141. So either this is the castles district, or some data might be wrong. And let's have a look at the 10 smallest values. And here we have two values below 1, so we have 0.84 and 0.88. And actually this doesn't really make sense, so we have less than one room per household. And also here the question is, should we remove those data points with extreme values, or should we find other appropriate values, or simply leave it as it is? And in this example we just leave it. So we have only two handful of extreme or suspicious values. So with over 20,000 valid observations, we could leave it here, but we can also further inspect those extreme values. So let's have a look at this observation here and those two observations. And let's have a look at rooms per household. And in this example here we have 132. So this is the castles district. And in total we have only 15 households and almost 2,000 rooms. And then the next two districts we have less than one room per household. So for instance here we have 11 rooms and we have 13 households, and also here we have 32 rooms and 36 households. So this doesn't really make sense, and we could delete these observations. But this doesn't really make a difference, and let's go on and let's create two additional features. So the population per household, and this is simply the population divided by the number of households. And last but not least, we also create bedrooms per room, so we divide total bedrooms by the total rooms. And finally, we can also have a look at some summary statistics. So for instance, here we have the three new features, and let's have a look at the mean values. So on average, we have 5.4 rooms per household and 3 persons per household and 0.21 bedrooms per room. And in the next lecture, we try to analyze if and how those new features could influence house values. So thanks for watching and see you there. Bye.